Welcome to this session on the PowerPack for Advanced Steel, and we're going to be taking a look at our new Lapjoint feature available in this version. Selecting the command, we can zoom in to the area of the model where we wish to apply the Lapjoint, in this case a railing splice position. We can see now that the joint has been applied to the two railing elements. The first tab we come to is plate definition, and under there we can control the thickness of the splice, and we can see it change as we enter in the dialog. The width of the splice is controlled here, either relative to the beam or an absolute value. When it's set to the default condition as relative, if you enter a figure in here, it will actually reduce the width there. If you change to absolute, this field becomes active in here, and you can change that value. We just pop back to relative to the field. We can obviously see it retained that value that we put in before. Similarly here, you can control the length. By typing in a length value, you'll see this increase. Also, you can decide whether you wish it on both sides, one side or the other side. So if we move it to the other side, it moves it to the top. If we apply it on both sides, it will put the lap plates on both sides. So the joint, although designed for railings, can be used in other splice conditions that require that type of assembly. The next way is an offset. This is a bias position, which actually biases the plate slightly relative to the central point. If we put that back to 10, we can see it move back to its original location. If we now move to the connection definition, we'll see that the different sides of the plate have different connectors on them. So side 1 is set to welded under the combo box here. So you have options for welded and bolted. Under welds, you have the typical options here for weld size, weld type, and most importantly, the weld location, which is defaulted to shop. If we toggle to side 2, we can see this is where the bolted option is currently set, and within that you can access the various parameters that are associated with the bolt type that's stored within the database. This particular bolt is a setless arrangement and has had no nut and washer associated with it. Typically the bolt can be reversed, toggling here. So if you toggle that now, the countersunk head is actually in the lap plate itself. So just putting that back to the default condition. The other element here is obviously the positioning tab, and we can see here the number of bolts can be controlled here by entering field values here. You can control the distance between the bolts by adjusting the figures in there, and that will close them up about a central location. You can offset the central location if you so wish, moving the bolts one side or the other by entering various figures within these two fields at the bottom. The final location is obviously the library. You can save your library entry by entering the name here, and then once it is stored in the library, it can be set as your default condition for the next time that you use the joint. The tool works with the copy tools of Advanced Steel, selecting the various elements that you need to apply the splice to. It works with the multiple condition as well, so we can come in and we can select those elements as we require. So here we're going to select this position down here, this position here, these two positions up here, and then we're going to select the secondary elements following the prompts for the joint. We can now see that the joints have been applied to those multiple locations within the railing assembly. That concludes the Lapjoint macro for PowerPack for Advanced Steel.